So, when the last video ended, we were talking about the altitudes and the pressure on the bottles. So, there's low air pressure outside in high altitudes. So, this is similar to Eureka's altitude. So, there's no pressure on the bottle. If you went down a little bit lower, like in Payson, it might press against it a little bit. And if you went even closer to like sea level, like to California, then you're really going to see that air pressure happen. So if we go back to our sheet, it says air pressure increases, so does the blank of the molecules. I haven't read about that one yet, so let's skip that one. The area above sea level has relatively low pressure. So this causes the air near the blank to flow towards the lower pressure over the. So the area above the sea has low pressure. No, actually, if it's talking about the sea level pressure, actually. So it has high pressure. This causes the air near the. I'm not sure about that one. Let's keep looking back at our slide and see if it's explained a little bit more in a minute. But for just a few minutes, I want you to brainstorm with each other. You can all be each other's partners. And I want you to answer the question, if air pressure is so strong and it's always pushing on us, why don't we collapse like the bottle? Why isn't the air pressure pushing towards us like a bottle? So go ahead and hit pause while you talk to each other about that. Okay, hopefully you was able to brainstorm and talk to each other about why we don't collapse. So the reason that we're not crushed by air pressure around us is because the external pressure is balanced by our internal pressure, which rises from various fluids and other materials in our body. So we have some internal air pressure in our body that pushes towards the external air pressure. And so because we have that air pressure in our body that pushes against that, we do not collapse. So over land and water, the surface of the sea warms up more slowly than the surface of land. So the top of the water, it warms up slower than the land. So as the temperature of the land rises, the land heats the air above it. So the air right above the land is going to be heated at a faster rate than the air above the sea. The warming air expands and becomes less dense, decreasing the pressure over the land near the coast. So it expands and you don't have as much, it's dense, and so it decreases the pressure over the land near the coast. So the air above the sea has relatively higher pressure, causing the area near the coast to flow towards the lower pressure over land. So I think that's the part we were talking about on our sheet. So it says the area above the sea is relatively, and so if I'm going to make this sheet just a little smaller for a second so we can look at what it says here. So the air above the sea is relatively higher pressure. So this should say is relatively higher pressure. This causes the air near the, let's go back to here. This causes the air near the coast to flow towards the lower pressure. So this causes the air near the shore, or the coast, I think it might have said coast, near the coast to flow towards the lower pressure over the land. So that makes a lot more sense now. So the area above the sea is relatively higher pressure. So it's higher pressure because the temperature is colder above the sea. So it causes the air near the coast to flow towards the low pressure over the land. So that high pressure over the sea will flow over to the land where the low pressure is. It's attracted to that. Okay, so it says the highest pressure at sea level when the density of the molecules is the greatest. So this was the question that we've been looking to answer. So it says low pressure goes towards high pressure. So 8 kilometers of pressure is going to go to 1 kilometer of pressure. So the air temperature is 15 Celsius. So it's higher pressure. So that low pressure wants to go to the high pressure. And over here on this side, that lower pressure at air of 25 wants to go to that high pressure. So the air reverts from the higher pressure to the lower. So if it's lower on land and higher in the air, it's going to go up. If it's lower in the air and higher, like on a lake, then the air pressure will go down, because that lower pressure is always trying to get to the higher pressure. So the air advects from the higher pressure area to the lower pressure. So it also goes across, like the higher pressure goes to the lower pressure. On this one, the higher pressure goes to the lower pressure. And so the water temperature is only 10 degrees Celsius, whereas the ground temperature might be 30 degrees Celsius. So the cool air is going to travel towards the warm air over the land. So in the air above the land, the pressure is going to be higher, and it's going to go over to the low pressure, and that cycle continues. So in conclusion, rising air creates low pressure, while sinking air creates high pressure. With high pressure, sinking air suppresses weather development. High pressure produces clear sky, dry and stable weather. A low pressure zone, wind is circulated inwards and upwards rapidly. As a result, air rises and cools and clouds are formed. Low air pressure produces unstable weather conditions like rain or storm. So we had that one question we still needed to answer. As air pressure increases, so does the blank of the molecules. So let's go back through our notes and see where it talks about the molecule. Okay. So I'm not seeing it. So it says as air pressure increases, so does the blank of the molecules. So if we think about the air pressure, and it says as it increases, as the air pressure increases, so there's higher pressure, then that means there's colder temperatures. So remember, with colder temperatures, your molecules are going to get tighter together. And with warmer temperatures, they're going to spread out. So if you think of like the little molecules as little balls, when it's warmer, they're spread out more. And when it's colder, they contract more. So as the air pressure increases, so when it's colder, so does the closeness of the molecules. So the more air pressure there is, the tighter the molecules will be. So I thought it would tell us that in the slideshow, but it didn't. So I had to kind of think about that one. So as it increases the closeness, it also increases the closeness of the molecules. Okay, so that is all of our information from our slideshow. So you should just have those notes filled out and that true false quiz filled out for the first time. So tomorrow there won't be a video, but you'll have this article that you'll read, and you'll use these close reading marks to mark your article, and then I'll grade that when you turn it in. And then on Wednesday, you'll do labs 1. And these are just short little labs. You'll do lab 2 and then lab 3. So you'll do those 3 labs. I've sent the instructions for labs 1 through 3, and then also the response sheet. So you'll fill out the lab write-up as you're doing the lab, and then the response sheet after. And then I've sent the instructions, and I really want Amber to be using the instructions and doing the lab with the instructions so that you can fill out your sheets as you go. So you'll do labs 1 through 3 on Wednesday, and then Thursday you'll do lab 4 through 6. So you'll have lab 4, 5, and 6. I have sent a few materials that I had that I thought you might need, that you might not have at home. If there's any other materials that you don't have at home that it says you need on the instructions, let me know, and I will try to get those to you. And then on Thursday, after you're done with all the labs, I want you to do the true false quiz again. And I'd like you to do it with a different colored pencil. So do it with another different color. You can do a colored pencil, crayon, a pen if you used a pencil, or a pencil if you used a pen. I just want you to not change any answers, but to see how many you changed. And I want you to talk about which ones you changed, which ones you thought were different than you think now, and what you learned through this week with our air pressure experiments, and then also the lesson that we did today. So this video will stay posted all week if you need to review it for what you're supposed to do this week. It will stay posted all week, but you shouldn't need to watch it every day unless you have questions about what should be done. So thanks for being such good students, and let me know how I can help you.